Hi, today I'm going to talk to you about inter-VLAN routing and see the possibilities we have that if we want the VLANs to communicate to each other. Because when we are setting up VLANs in switches, they are not able to communicate from one VLAN to another. On layer 2, this is impossible. So we need some kind of layer 3 device to be able to get the different devices on different VLANs to communicate with each other. And there are different ways of doing that. One way is to just add a router and to add a physical interface per VLAN, which is called the legacy configuration of intra-VLAN routing. This, of course, is not very scalable because we need a physical interface for each VLAN. And if we have a few VLANs, well, it's okay. If we have 30 VLANs, we basically would need a router with 30 physical Ethernet interfaces of some kind. And probably we don't have that. But this is the legacy inter-VLAN routing. Then we have something called router on a stick, where we use trunking, and we set up trunking to work with the routers as well. In this case, we use the 802.1q protocol for trunking, which is also the one that we are using on the switches. And we create sub-interfaces that can read the VLAN tags. So the different sub-interfaces will belong to the different VLANs. And we have one sub-interface per VLAN. So in this case, it is easy to scale because if you have a new VLAN, you just add another sub-interface. And then, of course, we set it up with the correct IP addresses according to the different VLANs, and the sub interface will then be the default gateway for each VLAN. So these are the two different ways of doing it, where we use a router. There is a third way, and that is to use a layer 3 switch, and I will present that in another video. So this is router on a stick. Let's first have a look at how to set it up if we don't want to use router on a stick, but we want to use the legacy way, the old-fashioned way of setting it up. Then we just need a router with the number of interfaces that we have VLANs, and then we just configure it basically in the normal way. So like here we have two different VLANs. We have VLAN 10 and we have VLAN 30. And to be able to communicate from VLAN 10 to VLAN 30, well, then we just set it up so that we connect fast Ethernet 04, which belongs to VLAN 10, to our interface G00, for instance, and then we set it up with the correct IP address. Same thing here on VLAN 30. We have a switch port here that belongs to VLAN 30 on a fast Ethernet 05, and we connect that to the other physical interface on the router, the G01. And then we set it up with the correct IP address that belongs to VLAN 30. And these two PCs that are on each VLANs, well, they just be set up with the router interface here as their default gateway. And this is basically the way that we need to set it up. The routing will be automatic here since we only have directly connected networks. So we don't need to set up any kind of routing process. So what do we do? Well, on the switch, we create the two VLANs, and then we assign the ports according to which VLAN it's supposed to belong to. So port 11 belongs to VLAN 10, port 4 belongs to VLAN 10, port 6 belongs to 30, and 5 to 30. And that's it. That's what we need to set up in the switch. In the router, however, we also need to set up the two different interfaces. So here we have interface G00 and G01. And we just set it up with the correct IP address that we want. This IP address belongs to VLAN 10 and the other one to VLAN 30. And we do a no shutdown on both of them. Then we will automatically perform routing between these two interfaces because they are directly connected and we don't need to do anything more about that. But of course, if I add a VLAN 99 or VLAN 40 or VLAN something, then I need to have one more physical interface to be able to route between the new VLAN as well. And that, of course, is the problem with this solution. It scales really, really bad. So let's have a look at how to do it on a router on a stick instead, where we use trunking. So we create sub-interfaces and we create a trunk port between the switch and the router. And then we set them up, of course, again with the correct IP addresses. So let's have a look at how to do that. On the switch, of course, we still need to assign the ports and create the VLANs. And then we now change fast Ethernet 05 to be a trunk port instead. And we do that with the command switch port mode trunk. So now port 5 is a trunk port and we'll be able to send information from all different VLANs. Then on the router, what we do is that we create sub-interfaces, one sub-interface for each VLAN. So for VLAN 10, we create a sub-interface called G00. G00 is the physical interface, and then we say dot and 10 for VLAN 10. Then we go in and say that now I will encapsulate this using the 802.1q protocol. And the command for that is encapsulation.1q. And then I indicate that this is on VLAN 10. And then I give it the correct IP address on the sub interface. Then I create a sub interface in the same way for VLAN 30. So G00.30 will create a sub interface. Then again, I need to tell them that I'm going to use the trunking protocol, so encapsulation.1q, and then 30 for VLAN 30, and then again the correct IP address. And that's it. Now I've created the two sub interfaces. Then I just need to open the physical interface. So go back to to Ethernet G00, and then I do a no shutdown on that. And that will open my physical interface and therefore also the sub-interfaces. So if I now add a third network VLAN, well then I just need to create one more sub-interface. So in this case, it's much easier to scale. So that is why if I want to use a router to route between my VLANs, I will do it on a router on a stick. And that's it. Thank you.